Point 2. Explanation for PR1, Part 2, Overflow. In this part, I want to explain the background for overflow. In this project, overflow is a big problem because when we calculate Fibonacci numbers, we can easily get to very big numbers. So then we can quickly hit that upper bound for our current data type. Here, let me talk about long integer, not just integer. So integer, int, that data type, we can get overflow even much more faster. For integer in Java, we use 4 bytes. Long integer, we use 8 bytes. Yeah. Even when we use 8 byte integer, still we can get overflow quickly. Yeah. All right, so here, this is part of our project description. In our project description, I give you examples based on my previous experience. When we use the long integer data type, we can get to the overflow when we calculate Fibonacci number at n equal 93. 93 it's not a very big number. Not a very big number. You can get overflow that quick. Yeah. So why is that? Here, let me explain a little bit. Yeah. Long integer, we need to use 64-bit. 8 bytes, 64-bit integer, right? Although it looks like there are many bits, right? 64 bits. But the highest one is the sign bit. Because we need to represent positive, negative. Okay? Positive, negative, 0. Yeah. Okay. Sign bit equals 1, that means it's a negative number. Sign bit equals 0, positive, but including 0, right? Including 0. Positive plus the 0 case. All 0, that's the 0 case. All right. That means other than the sign bit, we can only use the remaining 63 bits to represent the size of the integer. Then, what is the largest integer we can represent? 2 to the 63rd minus 1. So all 1, you pack all 1s in, not 30, in 63 positions. So you get this number. Okay? Yeah. Then your Fibonacci number f of n should be less than or equal to this number. Okay? Yeah. Then it's very easy. 93 will be greater than this number. Okay? We have formula. We can do calculation. We do not even need to, we can do experiment. So there are 2 ways you can get this bound. One way, experiment, doing experiment. Second way, using formula. We have the Fibonacci number formula. We can calculate this number. Yeah. All right. So next, I like to talk about the experiment way to detect overflow. Okay, yeah. Detect the overflow by experiments. How do you detect it? So here, we do A plus B equals C operation, right? A plus B equals C. Yeah. There is a possible overflow here. Sometimes you have it, sometimes you do not have it. So it's a possible overflow. Yeah. But in Java, when you have an overflow, no complaint from the machine. You do not know it. There is no complaint. You just keep getting the numbers. Yeah. But when overflow happens, the number is truncated. Okay, the number is truncated. That's a different number. The bits higher than the, normal bits, 64 bits, right? Higher than the normal bits will be truncated, throw away. So you will get a wrong number, but you do not know it. There is no error message, you will not know it. But how do you detect it? Yeah, here the idea is pretty simple. Okay, all right, so let me describe how do we detect it. All right, so we have an A number plus B number, we get a C number, right? Is there an overflow? So we consider two cases. The first case, no overflow, normal, right? Normal, so we get correct C. But there is another possible overflow case. You get a truncated number, so it won't be a C. So we call it a C1. Okay, so different number, C1. Okay, all right. Then after that, you do the checking. You verify if the result number is correct. So how do you do the verification? Okay, if you get a C1, so whatever the number is, C1 minus A, you compare it with B. Equal or not? Yeah. Equal or not? Okay. C minus A, compare it with B. Equal or not? If no overflow, must be equal, right? Must be equal. Okay? Yeah. If there is an overflow, not equal. Because truncated, you use that truncated number, do subtraction on A number, so you get number that's different from B. Okay, so not equal. Not equal. So you use this comparison, another comparison, you can detect if you get an overflow or not. Okay, yeah, all right. So that's the background about overflow. Yeah, but for this project, I do not ask you to do the detection, okay, checking, detection, verification. I do not ask you to do that. So if you are interested in this topic, you can do experiments by yourself. Okay, it's pretty interesting, not very hard. Yeah, you can easily detect the overflow point. Okay, all right. Then now, that's the reason we use big integer in Java, because big integer in Java using string to handle the big integer, represent big integer in string, in a long string. For a string, we know we can make it as long as we want. There is never overflow. Okay, so you can see in this way, Java uses a special big integer class. In that case, never overflow. Yeah, so that's pretty neat. Never overflow. Okay, yeah. I think Python uses the similar way. Python, there is a built-in support dealing with big integers. Yeah. All right. My next video, I will talk about basics of big integers. Yeah. I will show you my program, but at the same time, I explain basic operations of big integers. Then I post this program so you can study, so you can use the basic operations in your project. All right, so let me start my second video for project 1.